Hello, everybody. I'm going to talk about Qubic domination. So I'm Albert. I'm the ecosystem lead of Qubic, but more important, I'm a member of the community of Qubic. So let's start. What is the relation of all that we have all over the news in Cointelegraph, CoinDesk, since the last 2 months, talking about the relation between XMR, Qubic, and AGI. So for that, we have to introduce who we are. We are a community-led project. We don't have any VCs. It's very passionate people that join together to build something that right now we are like the 6th largest computer in the world if we combine all the power that we have in our decentralized network. And also, we are certified as the fastest blockchain with more than 50 million TPS in mainnet. This is certified by Qubic. But this is not the most important thing. The most important thing about Qubic is that we have a goal. All together, we are a community of more than 60,000 people that we have a goal. And our goal is that we are turning the distributed computing power into the foundational infrastructure where AGI can emerge. So what we are doing right now is gathering all the computational power, and building a very innovative solution where we can combine computational power with some tasks. So the goal is to have useful proof of work. Proof of work that the miner will be doing something that is going to be useful. How did it start in the past? So I have to introduce CSV. CSV is the founder. He's one of the first Bitcoin miners. And he had another 2 projects that he found. The first one is an NXT in 2013. And it was like purely because the industry was struggling to create a 100% proof-of-stake coin. So he did it in a few months as a test. And he proved a couple of years later that he was the founder of NXT. He is also the founder of IOTA, the first directed acyclic graph that was launched in 2016. And as a note, this was an ICO that has an initial valuation of 400,000 USD, and it became a more than 15 billion market cap project in a few months. So the ideation of Qubic started in 2012. With Qubic, he has an idea how to create an artificial general intelligence, but at that time, there was no infrastructure, there was no hardware capabilities to build that. So he started in 2012, and a couple of years and a half ago, he joined the community, he gathered all the people, and we started that. There is a definition that one member of the community said about CSV, and he told, he is a very good guy that looks like a very bad guy, And the way is that all the genius that we know, they behave like that. They are capable to see things that we don't see. We just see the pieces, but he's able to connect everything into his mind, and also he's capable to project that into a community for a common goal. Qubic, the governance, the most important thing that we have is that we have decoupled the mining power to the consensus algorithm. So it's like a competition where what we call the validators, we call them computers. They have to be the best of the best. They have to attract as much power as they can have to be part of the validators, the official validators of Qubic. And in the other hand, also, they must have attached mining power that at the beginning, we were just creating artificial neural networks. Now, since last year, we are also training these AIs. And the better you do, the more chances you have to be part of these 676 computers. But also, you have to be good when you are a computer. You must have the fastest transactions. If you don't do that, you will have less rewards. So what happened? We are doing this, gathering power for building this artificial general intelligence. But at some point, we were able to absorb so many computing power that it was too much. But for building this AGI, it's like pregnancy in women, you know? You need time. But if you have 2 pregnant women, you're not going to deliver the baby in half the time, you know? So we decided that with this remaining power that we have in the network, we could do something else. At the beginning, we did. We allowed the miners to have an ideal capacity to do other tasks. So they were able to have more profits. But at some point, we decided that maybe it's a very good idea to have like this computational power, the exist of computational power to mine another coin. And the community decided that it was going to be Monero. So they told us that it was impossible to do that. How on earth a blockchain is going to mine another coin without affecting the performance, without being in a scheme of rewards. But we managed to get an equivalent of the 51% of the hash rate of Monero. This is not a Christmas tree, what you have in the image. It's a reorganization that we did with a selfish mining algorithm in Monero to get more profit for that. So they told us that it was impossible, and we did it. At the beginning, it was, when we started with this, we gathered around 1% of the computational power, but each week, we're getting like double the computational power. Imagine this. We are a 300 million market cap blockchain, and Monero is at 6 billion. So how is it possible that such small, you know, that we are very early in Qubic, was capable to do that? So the secret sauce for that was that we have a technical affinity because we can have CPU and GPU, and also we did an economical hack. And this is the most interesting part. We applied game theory. I used to call it the mining black hole theory, where the rewards that we can give to the miners were a little bit greater than the Monero miners by its own. So we started to attract more miners. It's like the gravity. So it happened very quickly, and we managed also to apply and to execute a selfish mining algorithm. With this Monero that we mine, we sell them, and we make a buyback in Qubic. So those are burned. Also, it's part of a social activity. You are feeling like you have the feeling to be part of the group, that it's going to be the next thing. That's why we were able also to try to attract many miners, because they feel like they are in the forefront of Web3 and AI innovation. But many people consider that we were doing an attack, and it's quite the opposite. It's like when we are, you know, if we were doing an attack, we wouldn't have said in advance that we were going to do this exactly. And as you can see here in the chart, you have the price of Monero, and when we started with the interleaf mining of Qubic, you can see that it didn't affect the price. It's even the opposite. It affects positive. Why? Because we discovered security bugs that Monero had in the past. We just exposed them, and Monero community, they were able to fix them, you know? And in the other hand, we have been taking profit. Also, you know, likewise, they also try to do a revenge on us, like doing a very huge DDoS attacks. But we appreciate that because we also were able to enforce and to improve our network very easily thanks to that. So we save a lot of millions on security audits, on penetration testings, and we have it. So it was never meant to be an attack, but a demonstration how this algorithm could be implemented. And imagine this, we have achieved all of this only with 50% of the computing power. So what's happening with the remaining 50% of the computing power? So we are building a research project that is called Agarth. So Agarth means Garden of AIs. And the idea is that we are creating something, we are developing something that is not very common to the rest of the AIs. We are not based on tensors. We are not an LLM. It's something very, very different. So we are looking for the spark of intelligence that can be created by applying the evolution, the theory of evolution, to the computation. And we have the first prototype already. It's called Anna. Anna is a Twitter bot where it doesn't have any predefined training data. It has a self-refining architecture, and it's very highly adaptable to settings like Twitter, social media, where people can interact with her. Right now, you can ask her questions to Anna, and you will see that sometimes she gives wrong answers, you know? But this is the process of learning. One of the basic principles of learning is that in order to understand anything, you must make mistakes and learn from the mistakes. This self-learning process is what makes Agarth totally different for everything that you can think about. We also have a scientist team in the whole team, a neuroscientist that will be in the booth, so you can ask him questions, how we are applying this theory to the AGI. And what I want to say is that they told us that it was impossible to mine another coin with our network. We did it. Now, they are saying that it's impossible that we are going to achieve an artificial general intelligence. Do you think that we are not going to get it? You know, we like challenges. We are a huge community, very passionate people looking for the same goal, and the goal is to have this artificial general intelligence. We're going to have great news in the coming months related to listings, to extend, you know, the territory that we occupy. We are not now in the United States. Our plan is to be there. So please pass by our booth. Please drop out your questions and join the revolution. Join the smart domination of Qubic. Thank you so much.